Okay, Mark has a bag with different flavors of candy. The bag contains 4 cherry, 3 lemons, 7 watermelon, 2 grape. Which of the following shows the complement of selecting a grape? What does that word mean again? Opposite or
The other.
the not. We're looking for it not happening. So first we need what? Everything, which is 16. And then how many of them were not grape? 14. Oh, but I look and that answer's not there. How come? I can simplify it by dividing by 2, but then even 7/8, there's not one that looks like that, right? Because this means lots of things. That is a fraction. It also could mean to divide. It also could be written as a ratio, right? All those things are good. Okay. Any questions about that? Okay. All right, we have a quick video that we're going to show. All right. So on the notes, it says, a school uniform requires students to choose from a blue, green, or white polo shirt and either khaki shorts or navy shorts. So question A. A polo is randomly selected from a drawer with one of each color. Record the options in a list below. So what could we get on the polo shirts? That's right, blue, green, or white. Okay. Question B. It says a pair of shorts are randomly selected from the drawer with one of each color. Record the options in a list below. Well, what could he get there? Khaki or navy. Now notice, this time I have shortcutted it, okay? That's because if we know what we're talking about, you don't have to write the whole words out, okay? That would take a long time. All right? All right, now it says to use the tree diagram below to show the two events and the total possible outcomes when selecting a polo and a pair of shorts. So they've started the tree diagram for you. What goes up here? How do you know? Because that's the thing that there's 3 of, right? So this is blue. And does it matter if I change the order? No, it doesn't matter. Like I could have started with white, it wouldn't matter. Okay? So there, that represents my polo. Now I'm going to pull some shorts. So what goes underneath here? Khaki, navy. Khaki, navy. Like that, right? Okay. Now, C says to list the total possible outcomes when selecting a polo and a pair of shorts. So when they say make a list, you already have the tree diagram. So you know that you could pick blue with khaki, right? So blue with khaki. Or blue and navy. Does everybody see? I'm just making a list. Okay? And then, or we could have done green with khaki, green with navy, white with khaki, white with navy. Guys, that's called an organized list because I did not go blue with khaki, white with navy, green with khaki. I didn't skip around and go all over the place. I went systematically, meaning I did all the blue ones first, all the green ones next, and all the white ones. Okay? Over here, though, I missed this one. It says represent with another tree diagram. So on the right-hand side, you've got some space on the right. How else could we have drawn this instead of the way it was portrayed here? What do you think?
Basically, like no, khaki, navy like that.
Yeah, I could have done that, khaki and navy like that, and then I could have shown my shirts coming off of it like that. So go ahead and draw that, and you've got some space on the side. My blue, green, and white. Is one of these better than the other?
No.
No. What's the difference between them? Well, they still have the same outcomes, right? What's different? Well, one of them is horizontal, one of them is vertical, and one of them has me picking my shirt first versus the other one, I picked my shorts first. But does it really matter? No, because since you have to pick one of each, the order doesn't matter. Okay, so now the question D says, use the tree diagram and list. Your paper says or. Can you change that word to and? List to determine the probability of selecting a blue polo with khaki shorts. Okay, we need to underline some key stuff here. We need probability, so that tells me what kind of an answer am I looking for. what's the probability? So what kind of an answer am I looking for?
Yeah,
A fraction or a decimal or percent, okay? And I need blue with khaki, okay? Well, from the tree diagram, blue with khaki happened how many times? One time. Out of how many outfits did we make? 6. Very good. So that's how you do it from the tree diagram, okay? From the list, again, blue polo with khaki shorts happened one time out of 6. You see, you should still get the same answer. But I just want to make sure everyone knew how to answer the question from a tree diagram or a list. Does anyone have a question at this point? Because I did it. This answer I got from my tree diagram and this answer I got from the list. That's all. Yeah. Okay, let's look down here. The sample space describes all the possible outcomes of an event. Whatever that event is, okay? So if it can't happen, you don't need to include it, all right? If I'm talking about flipping a coin, then I don't care about a spinner and what's going on with the spinner, okay? Sample space can be displayed using a list or a tree diagram to determine the probability of simple or compound events. Okay, simple is everything we've done up until now. Compound is what we're getting into. So simple means I flip the coin once. All right, now I'm going to start flipping a coin, rolling a die, pick a card, whatever. Okay. All right, now we got some practice down here. Okay. It says a fair coin is tossed 3 times. What are all the possible outcomes, and how many total outcomes are possible? And then I have a note here to also use the fundamental counting principle. Okay, so we're actually going to do this 2 ways. We're going to do it with a tree diagram and with the fundamental counting principle. Okay, so toss number 1 happens. When toss number 1 happens, what could we get? Heads or tails? Perfect. Heads or tails. There's toss number 1. If I'm writing your right, I'm confused why some people are not writing. Okay, toss number 2 happens, and what could have happened on that coin? Heads or tails. But I have to go back to toss 1. If I got heads on toss 2, I could get heads or tails, right? But if I got tails on the second toss, on the first toss, then my second toss is still heads or tails. So this should look familiar, right? Does that remind you of something already? The video, that was the exact same one from the video. Now we're going to toss the 3rd time. Toss 3 is going to happen, right? How do I show that? I need to split all of these because it could have been heads, 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 right? Or heads, heads, tails. So each one of these can now, I could get heads or tails on my toss 3. Is everybody okay? All right, so the question is, how many total possible outcomes are there? And how do you know? There are 8, and how do we know? Well, no, we're not on that. I know from my picture because I counted all the ends. Remember on the video, we counted the tennis shoes? We counted all the tennis shoes. I'm counting my ends here. So 1, 2, 3, 4, 5, 6, 7, 8. Now, the fundamental counting principle is what you were trying to say. How many things just happened? What did we do? We tossed a coin 3 times. So that means toss 1, toss 2, toss 3. In toss 1, how many outcomes were there? 2, because it's a coin, right? How about on the second coin? How many outcomes were there? When I flipped my second coin, how many outcomes are there? Just 2. And how many outcomes are there on that third coin? Just 2. 2 times 2 times 2 is 8. So I like the fundamental counting principle because it's like a check. It's like proof that I did my thing right the first way and I answered it. So this is a good way to check yourself. Okay. Any questions? Okay, so what I'd like for you to do on the next page, there are 4 questions. We already did number 1. You're going to work with the table. If you're at home, pause the video. It said to, what are all the possible outcomes? So you could have either, in my opinion, if this was a quiz, you could have made a list. You could have put this tree diagram, or you could have put this tree diagram. So all of those answers would have been right because it said, what are all the possible outcomes? Okay? If it simply said, how many outcomes are there? And what's the answer? 6, because it was 3 times 2, which is 6. Okay? But any of those answers would work. What else? Can I answer anything else from these problems? Are we good?
I have a question on one of the problems on the homework.
Well, then that will be for tomorrow. Okay, so if you'll please turn your packet to the back, the very back page is blank. That's for you to use for space to do a Quizlet live.